Welcome to Get Your FRQ On. This question is from the 2004 Calculus AB exam. It's question 3, and it is calculator active. In the question stem, we're given a particle that is moving along the y-axis, and for time t greater than or equal to 0, the velocity of the particle is equal to 1 minus the inverse tangent of e to the t for time t. We are asked to find the acceleration of the particle at time t equals 2 in part A. Since we're given a function for the velocity of the particle at time t equals 0, the acceleration at time t equals 2 would just be the value of v prime of t at t equals 0. So for t greater than or equal to 0, the acceleration at time t is given by a of t equals v prime of t. It's a calculator active question, so we can calculate v prime of 2 using a calculator. A of 2, which is equal to v prime of 2, is just negative 0.133. In part B, we are asked if the speed of the particle is increasing or decreasing at time t equals 2, and to provide a justification. So the speed of the particle will be increasing at t equals 2 if the velocity and the acceleration at t equals 2 both have the same sign, and the speed will be decreasing at t equals 2 if the velocity and acceleration have different signs. So we just found the acceleration at time t equals 2. Now we need to find the velocity of the particle at time t equals 2 and then just compare the signs. So for part A, we know that a of 2 is negative 0.133. Since it's a calculator active question, we can use a calculator to calculate the value of v of 2. V of 2 is 1 minus the arctangent of e to the second power, which turns out to be negative 0.436. Note that both a of 2 and v of 2 are negative, and so they have the same sign. So because a of 2 and v of 2 are both negative at t equals 2, the speed of the particle is increasing. In part C, we are asked to find for what value of t is the height of the particle at a maximum and to provide justification. So the particle will reach its maximum height whenever the velocity turns out to be 0, is equal to 0. So we have a function for the velocity of the particle at time t, that's 1 minus the arctangent of e to the t. If I want that to equal 0, that would mean 1 would have to equal arctangent of e to the t. If I apply the inverse of arctangent, that would be tangent. So e to the t would equal the tangent of 1, and now I would apply the inverse of exponentiation with base e, which is the natural log. So the value of t that satisfies v of t equals 0 would be t equals the natural log of tangent 1. Right, this is also a calculator question, so we can use our calculator to determine the approximate value of natural log of tangent 1. That turns out to be about 0.443. To justify this, from the graph of v of t, we could see that v of t is positive when t is between 0 and the natural log of tangent 1, and v of t is negative when t is greater than the natural log of tangent 1. And since v of t is positive before that, negative after that, we can conclude that that represents the maximum height, or the time at which it occurs, the maximum height, 0.443 seconds. In part D, we are asked to determine the position of the particle at t equals 2, and then also determine if the particle is moving toward or away from the origin at that time. We're given in the question stem that the position of the particle at t equals 0 is already y of 0 equals negative 1. We do have to account for this, since where the particle starts in this whole process will affect where that particle is going to be at t equals 2. Right, the position of the particle at t equals 2 can be found by taking the definite integral and adding the initial condition, negative 1. So y of 2 would be negative 1 plus that integral from 0 to 2 of v of t dt. This is a calculator active question, so we're going to use our calculator to calculate the value of that definite integral, and it turns out that it's negative 1.361 when we factor in that negative 1. Now, whether the particle is moving toward or away from the origin depends on both the position of the particle at t equals 2, which we now know is negative, and the velocity of the particle at t equals 2, which is also negative. All right, y of 2 is less than 0. It's negative 1.361. V of 2 from the previous part is less than 0, so that's negative. So we are below the origin on the y-axis, and the velocity is negative, so this particle is moving away from the origin at t equals 2.